For all positive functions f and g of the real variable x, let tilde be a relation defined by, well, I'll call this equivalent. F is equivalent to g if and only if the limit as x approaches infinity of f of x over g of x is equal to 1. Which of the following is not a consequence of f equivalent to g? Okay, so I'll go through these one by one and try to eliminate the ones that are correct versus incorrect. So let's first write out the definition of this relation. F equivalent to g if and only if the limit as x approaches infinity of f of x divided by g of x is equal to 1. Okay, so let's talk about f squared equivalent to g squared and see if this is correct. Well, is it true that the limit as x approaches infinity of f squared x, is this equal to 1? Well, if this limit exists, it's equal to the limit as x approaches infinity of f of x over g of x squared, which is equal to 1. I mean, I'm convinced that that one will be correct. That was option A. So which of these is not a consequence? Well, that is a consequence, so that's the incorrect answer. Similar to the square root, yeah, so again, we note that the limit as x approaches infinity of root f of x divided by root g of x, well, this is going to be, this is again going to equal 1. We can interchange the limit with the root symbol. The root is a continuous function. I don't think nothing breaks here, so this is equal to the limit as x approaches infinity of f of x divided by g of x all under square root, and that's going to equal 1. So this is also not the right answer because that holds. So I'm fairly sure that the answer is going to be C, e to the f equivalent to e to the g. And the reason why we can't just make the same argument here, if we have e to the f of x divided by e to the g of x, I mean, this is not equal to e to the limit as x goes to infinity of f of x over g of x. And even if it were, this is equal to e. But there's not going to be a simple... I also don't have that this is equal to the limit. Well, in fact, this is equal to the limit as x approaches infinity of e to the f of x minus g of x. And we don't know anything about the difference between f and g, but we would need f minus g to approach 0 if we wanted this to be equal to 1, but that they don't have to be, right? As a counterexample, let's let f equal x and let's let g equal x plus 1. Then this is true, but f minus g is always equal to, a constant, which is not 0. This is almost certainly going to be the answer that we want, but let's just go ahead and look at the other options as well. So verifying f plus g equivalent to 2g, this will be true. If we just want to compute the limit as x approaches infinity of f plus g divided by 2g, well, this is the limit as x approaches infinity of f over 2g plus the limit as x approaches infinity of g over 2g. So this is equal to a half instantly because the g's cancel. And this is also equal to a half because we can factor this 1 over 2 out, and then I have the original limit, this one. So this statement is correct, meaning it's the wrong answer. Finally, option E g equivalent to f? Well, we're just taking a limit as x goes to infinity of gx over f of x, but that is the limit as x approaches infinity of 1 over f of x over g of x, and this is also equal to 1. Yeah. So the answer is C, and it basically comes down to, well, some simple, one, we found a counterexample. So a counterexample to show that option C does not hold is let f of x equal x and g of x equal x minus 1, right? Then, of course, f of x minus g of x is equal to 1. And so e to the f minus g is always equal to e. And so the limit does not, the limit that we want does not hold. But yeah, my intuition here was simply a few of these, the first two, the limit you want to compute can be written as a transformation of the original limit. Option D and E, well, option E, you can also do that. You can write the limit that you need to hold in terms of a transformation of the original limit. And just so, like, it just so happens that that transformation evaluated at 1 is equal to 1, right? 1 squared is 1, square root of 1 is 1, and 1 over 1 is 1. Option D, we know that holds because if two functions grow at the same rate, then adding those functions together means the result grows at, an added together rate, right? So in option D, the thing you have on both sides of the relation grow at a rate of 2, or they grow sort of, something on the left, like the f, when x is very large, the f can be replaced with g in some sense. But in option C, you just don't have the exact same type of simple relations of things going on. But it's a nice question to test either your instinct and understanding of the rate of growth of functions, or the relative rate of growth of two functions, and how transforming those functions either preserves or does not preserve that relative rate of growth. Thanks for watching.